So let's continue chapter 1. So as we said, cellular concept, we have a kind of adjacent channel interference because we could have imperfect SCVL filter. This could generate interference between the adjacent channel. Another example, another origin or reason is the nonlinearity of the amplifier. So in order to reduce that, we can use some modulation schemes with the low out-of-band radiation, or we carefully design the band pass filter. And one of the solution is to assign the adjacent channel to the different cell. So we will not use adjacent cell, channels in the same cells. We can use them to different cell. This will avoid the adjacent channel interference. Okay. And we continue with the radio propagation environment, and it's typically divided into different classes: urban, suburban, and rural. It's according to the population and the occupation of the ground. We could have another one, which is urban dense here, where there is a lot of occupation, and we could have also one here, which is really rural, with a few occupation. And the parameter is the ground occupation rate, which is a rate to let us know how much is the ratio between the area covered by the building and the total area of we are working with. And typically for urban, it's less than 1. For suburban, it's around 0.4. And for rural environment, it's less than 0.1. And if we want to characterize urban dense, it could be, for example, much greater than 1. In this case, in some books and in some specification, they call it urban dense. For uh, the other classification is that we have different kind of cells. It could be indoor and outdoor. Typically, outdoor cell could be macro cell or micro cell. The macro cell, they are cells to have with high coverage, and the base station antenna are typically placed above the average roof top level. And typically, the range of those cells could be up to 35 kilometers. Remember this 35 kilometers because we will see together why this value is the maximum range of UMT of a GSM cell or cellular cell. For the micro cell, its base station are below the average rooftop level, and it's a few hundred up to some kilometers, a couple of kilometers. So it's typically the base station that we have in urban area, and macro cells that are typically in suburban or in rural. And picocell, they are defined at some layer as microcell, and typically they are usually used indoor, for example, to cover, let's say, an indoor parking or some commercial center and so on. As you know, we already studied in the previous course in digital communication the different parameters that characterize the radio wave propagation, the multi-path channel, or those parameters. Remember, they are delay spread and coherence bandwidth, Doppler spread and coherence time, and we already investigated the characteristic of the fast fading and slow fading channel, and frequency selective and channel, and what's the path loss and how we calculate it in the different environment. So please check them in the previous course. I will add in this slide a new parameter which is very important for us, which is the angular spread that's defined or it describes the deviation of the signal incident angle. And usually we are interested the signal arriving or the signal coming to the base station antenna. So let's say we have a device here and we have a signal reflected to everyone. So here we have the angle deviation, and those are the deviation at the receiver, at the base station receiver, between the signal coming from the different copy of the same symbols. Okay. So here we can see also typical value for different environment of the radio characteristic channel, and you can see, for example, for macro cell in urban or suburban, the angle spread is between 5 and 10. For rural, it's around 5. For example, in indoor, it will be up. It will be because we have a lot of reflection and obstacle in indoor, so it's much higher than the urban and in macro cell. For the delay spread in macro cell, urban suburban, it's around 0.5 microsecond, but in indoor it's less than 0.1 because we don't have a lot of let's say space or distance. Here the fast fading is no line of sight for urban and suburban. It's possible to have a kind of line of sight in rural, and indoor it according to the let's say the position of the transmitter and the receiver. And here we have a kind of slow fading, where the slow fading is much higher in macro cell than in slow cell, okay, in indoor cell. At this level, we will give a brief description of the mobile network architecture. And you know that the mobile network is officially known as a public land mobile network, PLMN. Okay, and it's typically we have operator and that are in charge of the administration and the running of such mobile network. And the two typical technology we will see them. The architecture of GSM and UMTS are typically as follows. We have the user equipment, it's considered as a part, and we have the radio access network, and we have the core network, and we have the other network here. The other network could be the public switching telephony network, or the public or the packet data network, PDN, the packet data network. Here is the internet, and here is the classical telephony. It could be fixed or other mobile network. And generally, we have a well-defined interface between those components. So in the radio access network, we have for GSM the GRAN and for UMTS the UTRAN. And in the no core network, we have two domain, the circuit switched domain and the packet switched domain. In GSM and UMTS, we have the circuit switched domain because you know that the cellular concept was motivated by the telephony approach. So in the telephony approach, we have circuit switched mode, which means that the circuit is reserved for the use along the communication, like in the classical telephony. That's why we have the circuit switched domain, and after that we added the internet, which is the packet switched, and that's why we have the packet switched domain in the core network. The big difference is when we evaluate, where we have evolution to fourth generation or even fifth generation, we will see that we evolved toward a packet switched domain. So in the core network, we have the evolved packet domain, the evolved packet core, EPC. And here everything is packet switching, and it's really all IP-based system. It's what we call all IP-based system. Okay. And we have the user equipment, and we have the UTRAN. The UTRAN, it's also the LTE. We have the radio interface that's moving toward the LTE, and we define interfaces that can support, let's say, high bit rate. Okay, we will see in details those architecture in the next chapters. So this will end the first chapter, and I will move to the second one, and we will see GSM network.